march of stealth technology began with one revolutionary aircraft, born of a secrecy as black as its titanium airframe. What the Wright Flyer was to aviation in its earliest days, the F-117 Nighthawk has been to stealth technology.
From a historical standpoint, people are going to look back on the F-117, and it will certainly be a milestone. And it's just amazing to me that the thing was designed over 30 years ago, and it is still, you know, bar none, the best out there at what it does. And you need somebody to go in and provide precision munitions. There's nobody else to call, in my opinion, other than the F-117.
Developed by Lockheed's Skunk Works, the F-117 was the first stealth aircraft to be tested in combat. On December 19, 1989, 8 Nighthawks took part in Operation Just Cause, the military invasion of Panama. But it was Operation Desert Storm in 1991 that brought these fighters public acclaim. In nearly 1,300 missions, they accounted for 40% of all targets eliminated in the war. Despite the presence of hundreds of anti-aircraft artillery batteries and surface-to-air missiles, not a single stealth fighter was lost, proving the old axiom, you can't hit what you can't see. Lieutenant Colonel Joseph Salata was based with a 37th Tactical Fighter Wing Night Stalker Squadron in Saudi Arabia. He flew the F-117 in the first wave of black jets to attack Baghdad.
We sort of believed in stealth technology, but we hadn't really proven it at the time. I mean, we had done it in radar tests and so forth, but never in actual combat when there were actual bullets flying at you. So there was probably just a little bit of nervousness there until we saw what happened on the first night, and we saw how successful we really could be, and saw that the Skunk Works really did design a great stealth airplane.
The F-117s destroyed Saddam Hussein's key command and control centers, the heart of his integrated air defense system, and vital communication centers. In just one night, the black jets all but eliminated Iraq's ability to wage a coordinated war.
We had mission success rates that were unprecedented. You could almost guarantee that a target was going to be taken out by a stealth as long as we didn't have problems with weather or maintenance on our aircraft or something like that. As long as we got to the target, we had a very high success rate of killing that target.
The mysterious black jet sent shockwaves around the globe, putting military planners and governments on notice that every defensive radar system in the world was now useless against stealth technology.
This really changes the nature of warfare. To be able to go into a foreign country, be able to destroy a target without them even knowing you're there till the target's destroyed. They didn't know we destroyed those targets. They didn't know these planes were in country until there was smoke over Baghdad.
12 years later, in Operation Iraqi Freedom, the F-117 once again ruled the skies.
As far as what was it like to fly the stealth in Operation Iraqi Freedom, well, I'll be honest, I was a little bit nervous the first night. And so you rely on your training, and everything just kind of starts to flow, just like a normal type of sortie.
Throughout that whole campaign of over 100 sorties and 500 or 600 hours of flying, aircraft never took a scratch, and we were able to have about a 92% hit rate. Every combat mission that I flew in OIF, I never felt like I was being tracked. And I think from that standpoint, LO, paid for itself right there. You can get in there and get out and get your job done.
The combat success of the F-117 has set the standard for all low observable technology. The plane's origins date back to the early 70s, when the Pentagon asked military aircraft makers to submit designs for a fighter jet with reduced radar detectability. Those with the best design would win a contract to build 2 demonstration planes, codenamed Have Blue. In 1975, Dennis Overholzer was a 36-year-old software designer specializing in electromagnetic problems. In early May, Skunk Works project manager Dick Shearer asked him to solve an interesting problem.
Dick Shearer then asked me, how should we shape an airplane to make it invisible? And I says, well, it's rather straightforward from a radar cross-section viewpoint. I said, you just make it out of a lot of flat panels. You tilt the flat panels over, and you sweep the edges on the panels, and you put this together with a bunch of these flat panels. Well, Dick said, you've got to be kidding me, he said. Nobody says that. I said, well, you asked.
Overholser created new computer software called Echo 1. It calculated how each surface of a plane would scatter radar or electromagnetic waves that struck its surface. About a year later, the march toward stealth was advanced by Overholser's mentor, a retired former Skunkworks mathematician named Bill Schroeder. He came across an obscure scientific work written 15 years earlier by a little-known Russian physicist named Peter Ufimtsev. Ufimtsev had shown how to predict the directions a geometric configuration would scatter electromagnetic radiation. For Skunkworks, it was like finding the Rosetta Stone of stealth technology. It now had the design principles that would lead to the F-117.
The aircraft was designed 30 years ago by Lockheed Martin in the late 70s. And what they utilized was a type of stealth technology called a faceted shape design. And what that does is confuses any kind of a radar signal, and consequently we're able to maintain, for the most part, invisible against anybody that may be trying to detect our presence out there.
The discovery of Ufimtsev's work accelerated Skunkworks' plans for a flat-panel stealth design. It looked promising in theory. The only question now was how to make it fly. In the race for stealth technology in the mid-70s, Lockheed Martin put its money on an ambitious design. Skunkworks designers created a sketch for a plane made completely of flat sides. From above, the plane resembled an arrowhead or a diamond that had been beveled in 4 primary directions.
My good friend Dick Cantrell was head of aerodynamics, and of course, as one might expect, when Dick first saw some of the stealth designs we were coming up with, specifically our first diamond-shaped object, which he named the Hopeless Diamond, he had some serious doubts about it, and he came to me in kind of a confidence off to the side one day, and he said to me, he said, Dennis, is this really as low a cross-section as you're claiming? And I said, yes, it is. Dick thought for a moment, and then he says, well, he says, in that case, he says, we'll teach it to fly.
In 1976, Lockheed took a 10-foot model of their plane to the Air Force's radar test range. The results of the tests stunned both DARPA and the Air Force and won the development contract. Skunkworks had presented them with an aircraft that had the radar signature of an insect.
The results were dramatic, to say the least. 2 things happened immediately. The first of which is this fairly unclassified white world program immediately became black and was classified top secret. And black means in this context not just top secret, but unacknowledged. It was as black as the Manhattan Project. The other thing is DARPA and the Air Force and Lockheed got together and mutually funded the development of 2 low observable technology demonstration aircraft, the Have Blue aircraft.
The challenge now is to build a real airplane loaded with all kinds of non-stealth things, like a cockpit, engines, exhausts, and a pilot. The final Have Blue design was like nothing ever built, perhaps because it was the first ever conceived by electrical rather than aeronautical engineers. The plane was 39.8 feet long and weighed around 12,000 pounds. The leading edges of the wings were swept back to a razor-sharp 70 degrees. In late November 1977, the engineering team flew Have Blue to a secret airstrip in the Nevada desert. It was unloaded at night and placed in a hangar to conceal it from the prying eyes of Soviet satellites. On December 1st, 1977, Have Blue took to the skies for the first time. The fact that the plane even flew was an engineering miracle.
The instability of the aircraft in pitch, yaw, and roll, of course, pitch being the longitudinal force of the aircraft, and roll, and yaw, its side slip. So the parameters that control those motions of the aircraft were very, very critical in the development of the airplane. The original Have Blue airplane was the first aircraft to ever fly that was unstable in all three axes. And without fly-by-wire flight control systems, there would not have been a half-blue airplane.
Fly-by-wire flight control replaces mechanical controls with wires, sensors, computers, and actuators. In the decades since the flight system helped get half-blue off the ground, it's become standard equipment on all stealth aircraft.
And these are the pitot tubes that the aircraft uses to tell it where it's at, how high it is, how fast it's going. All four of these are hooked up to their own individual computer systems.
Even though the pilot of a fly-by-wire system still uses the standard stick and pedals, the computers assist by making constant adjustments. On November 16, 1978, the Air Force ordered 5 full-scale prototypes, or YF-117As. Skunk Works now had to adapt their design to account for such non-stealth items as a bomb bay, a weapons targeting system, radio antennas, and still keep it stealthy. The big question was, could it be done? The first prototype of the stealth jet, the YF-117A, was completed in the spring of 1981. It weighed 52,000 pounds and was 65 feet long, much larger than Half Blue. The wider shape of the plane met the Air Force's requirement that it carry up to 5,000 pounds of munitions. To accommodate the internal bomb bay, the prototype's swept wings were much broader than the original Half Blue. The F-117 has a similar structure today.
This is commonly referred to as a mile 12. Anyway, this is where our ordnance hang on, and it's in the down configuration. It's called a trapeze, and it actually will swing up into the airplane, and then they'll close the doors. And that reduces our exposure to the radar that are looking at us. So we come in, the door's open, the bomb comes off, the door's closed very, very quickly.
A desert camouflage scheme disguised the prototype's facets during daytime flight testing. The Air Force requested that all future planes be painted black for their intended role as night fighters.
The F-117 is designed and has operated at night. This goes back to the black world origins of the F-117 and continues to this day. It is a night fighter. It proved that stealth technology does work. The F-117 is an incredible aircraft that has far exceeded any expectations.
The Air Force ordered 29 planes. Eventually, Lockheed would produce 59 F-117s at a cost of $42.6 million per plane.
One of the hardest challenges was the fact that we wanted this airplane to look just like the hopeless diamond. We wanted perfectly flat, angled surfaces to appear to the radar. But to fly it, we had to take in air, we had to exhaust air, we had to have lights on the wingtips, we had to have a canopy for the pilot, we had to have an aperture for the infrared system to see through. So we ended up creating solutions, very innovative solutions to all of those challenges.
Among the most innovative of these was the platypus tail.
What the platypus does is shield the exhaust system of the airplane, which is very flat and very wide. All of the air that comes out of the engine is hot and washes over the platypus exhaust, which is basically constructed of high-temperature ceramic brick. And that brick is almost identical to the space shuttle tiles.
Instead of funneling all of the exhausts in a small location, what they did is they spread it out, and they utilized a special composite material on the aft end of the tailpipes, if you will. And what that does is also help to minimize the exhaust temperature. So hiding not just from the radar lookers, but also anybody that may be trying to see us from an infrared standpoint.
To further decrease the prototype's heat signature, engineers eliminated afterburners, which raised engine temperature by about 30%. In October 1979, the Air Force formed the 44 50th Tactical Fighter Wing near Tonopah, a remote town in the Nevada desert. The U.S. Air Force gave Colonel Bob Jackson the task of assembling the elite group that would make the F-117s operational. Lieutenant General Dennis R. Larson was a young captain when he was recruited for the secret program. His first interview with Colonel Jackson was typical of those conducted with the program's other pilots.
When I walked in the door, he said, "I want to hire you for a job. All I can tell you is that it's a great job. I can't tell you where you're going to live, except for it's going to be in the desert. I can't tell you whether you're going to be flying, and that's all I can tell you. Are you interested?" And I waited about 2 seconds, I think, or something like that, and says, "I'll take the job."
At Tonopah, pilots were introduced to the black jets in a scene right out of a Hollywood movie.
Normally we tried to show the pilots the airplane in the dark at night with the hangar doors just partially opened, big American flag over the top of the airplane hanging from the top of the hangar, and your heart just kind of got up into your throat.
For security reasons, pilots were forced to sleep during the day and fly at night for the first 6 years.
The people who worked on that fighter when it was still in the black world referred to this as the vampire convention, because they would have to rush home, get the aircraft in the hangar, and be back by sunrise.
The F-117A came out of the black on November 10, 1988, when the Defense Department released this purposely fuzzy photo to the public.